All right. Elijah's making me laugh because he's reminding everyone that you need to also do section 6.2, which I sent out on a video. Just what you guys want to do. So happy Martin Luther King Day to everybody. Thanks for joining today. I get to see you all on Monday, next Monday. Yay, right? Probably not excited about that, but probably excited about seeing your friends, I'm guessing. Co-op starts next Monday. Yep. You got to come back. You don't even know. Yes, next Monday co-op begins, so come back. You can see your friends and do some math too. I really know you're looking forward to the math part of it. Okay, one more minute and then we're going to start. So today we're actually going to, what I'm going to try to do is do 6.3, 6.4, and 6.5. The reason I want to get to 6.5 is because it's graphing. It's a really easy little graphing section. And 6.3 and 6.4 actually aren't that terrible. So are you laughing at my ability to get through those sections, Elijah? Yeah, I think I'm going to clear 3 sections. Thanks. Thanks, Elijah. All right, so let's go ahead and get started then. How does that sound? So what we are going to do is we're going to talk about functions again. So our good old friends functions are coming back. Remember function, well, here we go. We've got a bunch of different functions listed up here. We say like this function would be h of x, and then we have f of x and g of x. Those are 3 different functions that we have. And function's kind of a specific subcategory of an equation. So really in my math brain, when I see a function, I just kind of think of this as my y in the equation. Actually, if we go down here, this would probably be easier to look at. So let me, if I can get my whiteboard to work. So here would be a particular function. F of x equals negative 3x to the 1/3 power plus 4x to the 1/2 power. So that would be an example of a function. When I'm practically doing something with a function, I treat f of x like y, right? You remember that? It's, you see that terminology, and it's like, what do I do with f of x? But it's really like you're just kind of using it like a y. And we can evaluate these functions. So if I have f of x equals negative 3x, you know, this expression right here, and we wanted to know what happens when x equals 0, then that practically means you're going to have, instead of f of x, you want, what is the function when x equals 0? So you would say f of 0, and since everything in here is 0, f of 0 would be 0. And if you recall, there's some specific things that are specific to functions versus just an equation with y equals. So the big one is that functions can only have, for every x that you put in, for every input, you can only have exactly one output. So you can't have, you put in 2 and then you could get -1 or +1. One relationship, or the vertical line test. So kind of remember that back in your brain somewhere. Hey, Daniel. Functions are fun. Yes, maybe. Everybody still there? You didn't fall asleep yet? Three times turned under credit. Oh, man. I do miss you guys. Yeah, so technically the definition of a function is a relation for which each input has exactly one output. So that's what makes it a function versus y. Okay, so what we're going to talk about is called perform function operations and composition. So this actually is not very difficult. Actually, believe me on this one, it's not very difficult. So what we're going to talk about is if you have two functions, f of x and g of x, we can actually do some operations to those to create a new function. So you can add two functions together. So you can say f of x plus g of x, I add those together and I get a new function, which is h of x. I can subtract two functions from each other. I can multiply two functions by each other, and I can divide two functions by each other. So what does this look like practically? It's actually not too bad. It looks, Elijah says, what in the world? It looks crazy, but I promise it's not that crazy. Okay, so x equals yz. Where's that at? I don't even see that on mine. So let's start here. We have two functions. We have f of x equals, oh, okay. You put the functions as letters, gotcha. Well, let's just look at this, Elijah. It's really not too bad. So you've got f of x equals this function here, or this expression here, and you have g of x equals 5x to the 1/3, if I can draw right. 5x to the 1/3 plus 4x to the 1/2 power. So these are two different functions. They're separate. If I wanted to add g of x and f of x together, what would I do? Yeah, Elijah says, as long as they state their functions, I don't have to write them, and bam, easy. Gotcha. So if you want to add two functions together, what you're going to do is you're just going to substitute in what the function is and add it together. So g of x is, and this is the painful part, watch me write it. G of x is 5x to the 1/3 plus 4x to the 1/2, right? And then I'm adding that. So this is g of x plus f of x. F of x is negative 3x to the 1/3 plus 4x to the 1/2. Like I said, the painful part is watching me write this out. So if I want to add these two functions together, guess what I do? I add them together. So f of x, or 5x to the 1/3 power plus negative 3x to the 1/3 power would give me 2x to the 1/3 power. So I'm just adding like terms, just like we have done. I know you guys have done this in Algebra 1. I know we've done it in Algebra 2. You look for like terms. So this has an x to the 1/3 and this has an x to the 1/3 power. So I can add these together, right? And then can I add x to the 1/2 and x to the 1/2 power? Yeah, I can add those together. So I have 4x to the 1/2 power plus 4x to the 1/2 power, and I get 8x to the 1/2 power. All right, so that's all that is. If you want to add two functions together, you plug in each function and you add it together. Not hard, right? I hope not. Okay, so what about part B? I have g of x minus f of x. So instead of you guys painfully watching me rewrite everything, I'm just going to switch colors here. I'll do green. Okay, so instead I have g of x minus, instead of plus, minus f of x. So the one trick with subtraction is that you're subtracting the whole, I don't even know what colorblind colors are. Elijah's harassing me about what colors I'm using. I don't have very many choices in here. When you're subtracting a function from another function, make sure you subtract all the terms in that function. So this shouldn't be any surprise, right? you're going to subtract both of these terms, right? So we're going to do, again, this is part A right here. Part B, we're going to subtract g of x minus f of x. So g of x is 5x to the 1/3 power minus a negative 3x to the 1/3 power. So when you subtract a negative, that becomes adding a positive, right? So we should get 8x to the 1/3 power. Okay. And then I have my second term is 4x to the 1/2 power minus 4x to the 1/2 power. Oh, those cancel each other out, right? 4x to the 1/2 minus 4x to the 1/2 is just 0. So that's part B. Okay, any questions about that? Pretty easy, right? They throw in there the whole idea of function terminology, but basically you're just adding to, we already did this, yeah. Well, technically we did this before, Elijah, but we didn't do it with functions. We did it with equations, right? All right, so then what do you think you do with, I'll just go with black. What do you think we do if we have h of x equals 4x to the 2/3 power and t of x equals 5x to the 1/2 power, and I want to multiply those together? Shocker. You're going to multiply them together. So 4x to the 2/3 power times 5x to the 1/2 power, right? Now, this is where last Monday, we remember we went over all those exponent rules. So they're coming back again, right? So we can definitely do 4 times 5, that's 20. Now we have x to the 2/3 power times x to the 1/2 power. So when we are multiplying, and they have the same base, they both have a base of x, then we add the exponents together. That is one of our rules out there, right? So it's basically x to the 2/3 plus 1/2 power, which if you do some simplifying, you get, it's painful, my pen broke that I can write on my screen, x to the 7/6 power. Okay. So then, big surprise, if we would do if we do division, you're just going to plug in h of x divided by t of x is going to be 4x, this is much faster, to the 2/3 power divided by 5x to the 1/2 power. Okay. 4/5, we can't do anything with that, right? So it's just going to be 4/5. And then when we have exponents, we have 2/3, x to the 2/3 divided by x to the 1/2. When we're dividing, we subtract it. So it's going to be 2/3. That's supposed to be a 3 minus 1/2. That's supposed to be a 2. That's what happens when I'm trying to draw 2/2. Okay, and this is a 3. Sorry for the messy work. So when I subtract those, I get 4/5 x to the 1/6 power. So not so hard, right? All right, Elijah's got a running conversation. He's got a question for me. Okay, if you're multiplying, dividing exponents with different values, okay, I'm with you. So we have here, we're multiplying x to the 2/3 times x to the 1/2. Oh, what are the rules? So the rule is when you have, it's like this, a to the n times a to the m, that's the same as a to the m plus n. Could I pick any harder letters? So basically, as long as you have the same base, Elijah, the exponents, if you're multiplying, you add the two exponents together. What happens if you don't? You can't do anything with them. Like if this was x to the 2/3, y to the 1/2, then you can't do anything with that. They have to have the same one. I wish I would have done question. You just leave it like it is. Yep, so that would be the final answer. You couldn't combine the x and the y's. And then the Daniel says, why not make the 2/3 into 4/6 and the 1/2 into 3/6? Yes, that's what you should do, Daniel. And I was just kind of being lazy and not writing that out. So up here, this should be 4/6 plus 3/6, which will give you 7/6. You got it, Daniel. And then down here, you're going to have 4/6 minus 3/6. Okay. In that case, we could technically change the base value accordingly because of mixed numbers. The base values. Well, you can use your fraction rules to combine them together. And if you're not a fraction person, you can use your calculator to help you out if that really is what throws you off. Yeah, fractions still can be made into decimals, as Elijah says. Yes, that is true. All right, so that is one way that we can kind of manipulate functions around. The other way is called a composition, and I actually remember doing this several times in my college math career. So this is something that will come up again if you take more math as you go on. This also looks complicated, but is not that complicated. Okay, so we've got I don't know, Elijah. All right, so we've got f of x equals 3x minus 8, and we have g of x, which equals 2x squared. So what we're going to do is we're going to do a composition of the two functions. So what this means is that we're going to combine them together by plugging basically one equation into the other equation. Okay, so what this is saying, so remember how this f of x, this is your x. So if you wanted to know f of 0, right, that just basically means what happens when x equals 0. F of 0 means what happens when x equals 0. Well, instead we want to know what's f of g of x. So basically we're saying what happens if x equals g of x. So we're plugging in one into the other. So let me show you what this looks like. So we've got f of g of x. Okay, whatever is in, the way that functions are written, f of x, this is basically what you're plugging in, right? X equals 1, x equals 100, whatever it is. In this case, we're plugging in g of x, and g of x is 2x squared. So what we're finding is f of, and instead of g of x, we're going to write f of 2x squared. Okay, which practically means that f of x, right? F of x is 3x minus 8. And we just said that our x is going to be 2x squared. So we need to plug that in for x over here. So f of 2x squared equals 3 times 2x squared minus 8. Okay, 3 times 2x squared is 6x squared minus 8. So f of g of x is 6x squared minus 8. So what this is practically doing is plugging g of x into f of x, and it's called a composition of functions. So it's combining those two together. Okay, did you guys follow along with that, or did I lose you on that one? It is written down. Okay. Lost you. Okay, let me do another one, okay? Bring back the purple marker. Let's do G. Well, let's just do one thing first here. So this is not, I promise, it's not that bad. It just looks hard. Okay. Let's just do this first. You've got G of X, right? Equals 2x squared. So do you remember how to do what's G of, let's see, G of 3? How would you do that? That means what you're going to do is you're going to say, okay, that's not that. Erase that one off. Okay. What that means is you're going to plug 3 in as your x value. Yeah, Elijah's got it. It's going to be 2 times 3 squared. Okay, and then you can evaluate from there. So G of 3 is going to be 18. Okay, so we're okay with that. But what they're telling you to do is to, instead of a value for that x, they're telling you to plug in f of x. So before we plugged in 3, but now for our value of x, we're going to plug in f of x. Okay, so our original equation is still 2 times x squared, right? But f of x, this is where we need some color coding. F of x, right, is 3x minus 8. So instead of x here, we're going to write 3x minus 8. 8. Okay, so then we can simplify this. Actually, we could just leave it like that. So G of f of x would be 2 times 3x minus 8 squared, and you could FOIL that 3x minus 8 squared and FOIL it and get a different form of that equation, but I don't want to get lost in the math. I want to get back to the kind of the idea. Okay, so let me do another one. I think I'll do several of them so you can kind of see what that pattern kind of looks like. Okay, so, oh gosh, Elijah just wrote me a book here. F of x is the basic designation for x. And then use this equation. We can solve things such as g of f(x). I think we're on the same page with that, Elijah. I think we're good. All right, so let me do another one from your book. Paint. So let's do number, let's see. Let's do 29, okay? So what they want you to find, and number 29, is G of f of x, okay? And then what's given is that f of x equals 3x to the negative 1 power, and g of x equals 2x, make sure I'm getting the right one down, minus 7. Okay? So what they're telling you is that they want you to find the function g of x, and they want you to evaluate x as f of x. That just sounded like a whole lot of letters in there, didn't it? Okay, so we'll start off with our g. G of, and then we're going to do f of x. So we know that g of x is 2 times x, and I'm going to leave a little blank here, minus 7. Okay, that's our bank over there of what we're working on, right? But what, instead of finding g for a certain value, we want to know what g of f of x is. And so this is going to be like our x that we're plugging in. Okay, so instead of x here, where it was in the g, we're going to plug in f of x, which is 3x to the minus 1 power. So if we evaluate this, right, it's going to be 2 times 3, 6, x to the negative 1 minus 7 is how we would write g of f of x. I don't know if that color coding helped or not. But basically, you're plugging one function into the other function. Nope, that's it. Elijah said, is that it? That's it. That is it, nada else. So then, I don't know which, let's see. Oh, number 28, which you don't have to do. So you're not interested in it, right? Number 28 is f, let me see if I can, I gotta keep up on my color coding here. I can't make the eraser bigger in here, let's see. An inverse function, Elijah, actually means that it's an x to the negative 1 power. So it's the inverse of the standard, x to the first power. No, it's not. You can graph x to the negative 1 power. Actually, when we get to graphing, let me graph it for you because it's kind of cool to see. All right, so let's do really quickly. If we had to do, nope, it's not imaginary, I promise. It's just the inverse of your other number. You're the one graphing. Graphing's not all bad. We got tools to help us. Elijah, we'll just table that for a minute. Let me just finish up with this to make sure everybody's got this concept down of tabling. Yes, bring it back though. Not saying we won't talk about it, but let me just come back to that. All right, so what if we wanted to do f of g of x, which is number 28. So you guys don't have to do this for homework, so you're not as excited about it, right? So basically what this means is that f of x is 3x to the negative 1 power. So we've got 3x to the negative 1 power, right? And instead of x, we're using g of x. So g of x is 2x minus 7. And that's kind of ugly. Probably your book is going to rewrite that as f of g of x equals 3 over 2x minus 7. I'm guessing that's how they wrote that pretty, but I could be wrong. So substituting one in for the other. Okay, and then there's one more kind of caveat to this, which actually has two options how to solve. So let me actually do number 21 from your book to show you what your options are for that, okay? So number 21, well, yeah, what's the easier option? I'll let you guys decide. Okay, we've got, this is also from your book, and for some reason they made the equations different. I don't know why they did this. So g of x equals negative x squared. Okay. Teaches one thing, shows another. This is the same thing. Oh, the book. Yeah, the book different. Okay, f of x equals 3x plus 2. Okay. So what they want to do in number 21 is they want you to find g, we're good with that, g of f of 2. Your mind blown yet? So two options for this, okay? One is that we can ignore that there's a 2 in there. Oh, I know you guys love two options, right? Draw a line down the middle. One is that we can substitute in f of 2 first and then put that in as g. And the second is that we can substitute the whole thing and then put 2 in at the end. So let me show you what I mean by that. First, we're going to figure out, okay, so we know we have f of 2. So f of 2 is just 3 times 2 plus 2. So f of 2 is 8, right? And we want to know what g of f of 2 is. Well, we just figured out f of 2 is 8. So we want to know what g of 8 is. And I should be writing that in green. We want to know what g, that's not going to work. There we go. We want to know what g of 8 is. Okay. And that just basically means we know that g of x is negative x squared. So g of 8 would be negative 8 squared. So negative 64. Okay, that's option 1. Option 2 is to kind of ignore the fact that you have the 2 in there until the end and do what we just did in the last few examples. So you could just figure out, okay, what is g of f of x? Okay, so g is negative x squared, and f of x is 3x plus 2. Okay, so we have that g of f of x is negative 3x plus 2 squared. And we want to know what happens when x equals 2. So we just plug that in. 3 times 2 plus 2 squared. And if we do all that work, 3 times 2 is 6, plus 2 is 8. Square that, and you're also going to end up with me running out of room, or negative 64. I think it is all right, Elijah. I think. So you can use either method. You can solve the one function for the value first and then plug it into the other, or you can solve what the function composition is first and then solve. This method would be better if you have to do multiple values. If you just have to do one, this one might be a little easier. It's kind of up to you. Whatever method your brain remembers is also a good bet. All right, so how do you guys feel about that? More examples? Feel like, okay, I think I could get it enough. This is the worst thing ever. What do you guys think? About this section? Any questions about this section? Nope, good. All right, cool. Good, awesome. All right, so since we're already 40 minutes in, what I'm gonna do is I'm gonna go ahead and do 6.5 next. We're skipping completely 6.4. I'm gonna do 6.5 because it is a graphing section. And so I wanna go ahead and do that online because it's easier to obviously see my screen than in a classroom. And then we'll see how much time we have. If not, what we'll do is do 6.4 and 6.6 when we get back next Monday. Now that was 6.3. I could have said the wrong thing. Yes. So last Monday we did 6.1. I did a recording of 6.2 online. We just went over 6.3. And then now we're going to skip to 6.5 just to confuse you guys. Not really. Okay. So yeah, 6.5 is pretty easy. There's one little thing that we want to talk about. And actually 6.4 is not too bad. It also is one of those sections that looks intimidating, but it's not really that intimidating. So graph, square root, and cube root functions is 6.5. So the hardest part of this is typing in it. No, I'm just kidding. The hardest part of this is actually figuring out the domain and range, because you guys can all type things into your calculator. But let's talk about what that looks like. So graph and state the domain and range, and we're going to do square root and cube root functions. So we're not even doing any higher functions than that. Let's see if this lets me. Nah, it probably won't. So first we have y equals -3 square root of x. Uh-oh, I got to read what you're saying here. This is there. There. Start graphing. Okay, so obviously you can do this on any graphing calculator, right? Y equals -3, and then we want to do square root of x. All right. Okay. I just had a thought. I wonder if it does, if you can do f of x. Oh, okay. Desmos is cool with that. Other graphing calculators are not. All right. Hardest part of this is putting the Desmos. It does. Oh, okay. So what I mean by figuring out what the domain and range is this. So obviously you guys can all type into your graphing calculators and you can see, observe. Actually, what I should have done is started with just the standard square root. So if you just have y equals the square root of x, you get a graph that looks like this, which is interesting, right? I guess I'll leave that up here. It's interesting. It stops at 0. Stops at 0. Why does it stop at 0? Well, think about it. If you have x equals -1, right? Let's say x equals -1. Then what you're asking Desmos to do is y equals the square root of -1. And we talked about this. Calculators get very, you can't square negatives, right? Calculators get very cranky with the negative numbers, and that's why we have I. You knew I was coming back. That's why we have I. But we can't graph. I'm sure there's some, supercomputers out there that can do imaginary ones. There you go, Elijah. You invent that. But for our purposes, we don't graph on the imaginary plane. We're just graphing on the real number plane. And so that's why our graph stops at 0. Okay, so for this particular graph, if I wanted to state the domain and range, question is, would you know how to do that? So domain, just a reminder, domain stands for your x's. So the domain of this particular graph is, well, here's one question. Can x equal 0? It can equal 0, right? So the domain means that x has to be greater than, yep, that's right, James. X has to be n or equal to 0. So that would be, you can graph this, you can show the graph. The domain is x is greater than or equal to 0. The range is your y's, and your y values are that y also has to be greater than or equal to 0. Yep, domain, yep. All right, so what happens to that original problem that was -3? So x equals -3 times square root of x. So I have to grab that. Obviously, you can graph it, but my domain changes a little bit, right? So my domain, my domain's the same. X has to be greater than or equal to 0. It can't be less than 0. But my range is now that y has to be not greater than or equal to 0. Y actually has to be less than or equal to 0. So that's the trickiest part of that. Okay, so let's try example number 2, which is y equals -1/2, and then we have the cube root of x. So several ways you could do this. Remember, you can write x to the 1/3 power, because that's one way to write cube root, or you can find it in Desmos. It's in there somewhere. I think it's under functions. Where do we find it? Miscellaneous functions. Here we go. So you can find it under functions with this little n square root. So you can do cube root of x. So both of those are valid ways to write the cubed root in Desmos. Okay. Elijah was just asking homework. The homework will be 6.3 and 6.5. I don't think we're going to get to 6.6 unless I talk really fast. Okay, so what would be the domain and range of this? This is the question. What do you think the domain is? So remember, domain is x's. So I think the domain of this would be, yeah, I think what you're saying, Elijah, is it's all real, right? It can go all the way from far negative as you can get to all the way as far positive as you can get. So when we have that situation, we call that all real. And I can just scroll out here. You can see it just keeps going forever and ever and ever, right? The range is our y's. So the y values are obviously growing more slowly than the x values. But if we zoom out far enough, we can get our y values to get as big or as small as we want. So our domain and our range are both actually going to be all real numbers. Yep, it's constantly growing. Exactly, Elijah. So when you have any situation, then we would say that it's all real numbers. Yep. I don't know if that would be a representation for that, Elijah. I would know what you mean, but if you gave that to a different math teacher, they might say, what is this? Okay, let's do let's see. Let's do number 17 in your book. It says graph the function, then state the domain and range. So number 17 is y equals x plus 1 to the 1/2 power plus 8. This is an interesting looking graph, isn't it? Okay, so one thing to note is why is it in this section? Well, this is technically a square root because this 1/2 power, you could also put this as the square root of x plus 1. Right? You could rewrite that either way, so just a reminder about that. So if we want to figure out what the domain and range is, we're going to have to do a little investigation here. So let me zoom in a little bit. Domain, remember, is all of your x values. And we want to see right here, where does this start at? X equals -1, y equals 8. I wish I could get that to stay up on there. X equals -1, y equals 8. So our domain for this particular graph would be that x has to be greater than or equal to -1. So we can't have any x values that are less than -1. So -5 is not going to work because we're going to end up with the whole problem with negative square roots, right? Our range, so what I mean by that domain practically is it's all the numbers that go this way. I should draw it on the x-axis. That's our domain, right? Our range talks about our y's. So the range is like this way, right? Y has to be greater than or equal to 8. I'm glad you think it's easy, Elijah. It's good to have an easy section in there, right? I just always want to point that out because I do, it is pretty easy, but I do think it's actually helpful, not just even in this section, but that whole idea of domain and range applies to anything that you graph. And so I know, Elijah, you asked earlier about something about, is it going to be on my ACT? Domain and range are a very common terminology that you're expected to understand in math. So make sure that you understand, remember, domain is your x's and range is your y's. And whenever people are talking about domain and range, they're talking about what values hold true for that equation. So this lesson is beyond just, square root graphs. You should be able to find the domain and range for any function that comes up. And sometimes people do get tripped up by that, so it has a bigger picture. Okay, so I ran out of time. I didn't make through my 3 sections. What we're going to talk about actually, so Elijah, what you were kind of asking about was the inverse function. We're actually going to talk about that next. That's not what I'm looking for. It's my geometry notes. We're going to actually talk about finding the inverse of a function, which looks really messy, but it's not too bad. On Monday, we'll talk about it on Monday. And then solving radical expressions. We are going to do Fridays. I can go over it on Friday if you want. Yeah, radical equation. Radical just basically means this sign is the radical. No, not that kind of radical. Yes, we will have Friday classes resuming next week when we start having Monday and Friday. I just thought for now I'll be nice to you guys. We'll just kind of ease back into it, and then we'll continue on. Yes, after co-op starts, we will have Fridays. So, which means after next Monday, we'll actually be done with chapter 6. So, be ready to turn your homework in and work on tests pretty quickly after that. After, yes, after the, let's see, I can add numbers together. After next Monday, the following Monday, the homework will be due. So, what date is that? No. So, this is today. Next Monday, we'll go over the last 2 sections, and homework will be due on the 30th. And I'll probably also give you guys the test, which you could turn in on the 30th also. So that way, if you have a bunch of other homework from classes due on the 23rd, it's not all kind of in one day. So yes, I will see you all next Monday. We will finish chapter 6 for sure on Monday. I would highly recommend just turning in your chapter 6 homework and test on the 30th and getting it all done. But definitely your homework will be due on the 30th. All right. So have fun with that stuff. Let me know if you have any questions. Have fun doing your art, Daniel. Thanks for joining me today. Bye. Thanks, guys. Bye.